Alright, so we need to find the area enclosed between the x-axis, the y, the graphs, and these ones here, between the x-axis and those graphs. So I'm assuming that there's some kind of a triangle that's going to be formed. Okay, so let's just look first at this one here. So since it's written in standard form is ax plus by is equal to c, and the coefficients and the constants have to be integers to be in that form. But anyway, the easiest way to graph that is just to use the x and y intercepts. Okay, and we know what the x-intercept is when y is equal to 0, and the y-intercept is when x is equal to 0, right? You know, wherever it crosses this axis, the y value is 0. Wherever it crosses this axis, the x value is 0. Okay, so if I substitute, I could do mental math on this one. If I substitute 0 in for y, alright, then we know x is going to be 20. And if I substitute 0 in for x, then y is going to be 20. Okay, which makes me think that maybe I should go by 5s here. Okay, so let's see. This is going to be, let's see. That one there might not be the best. Okay, so let's go by, this is going to be 5s. So 5, 10, 15, 20, and we go 5, 10, 15, 20. Okay, so if I insert my line there, okay, I'll make it red afterwards. Try to be as accurate as I can here. And let's just extend those just a little. So I can extend that there. I don't know how far it goes, where that triangle is going to form, so try to be careful here. And same with this one. Alright, so it looks like a slope of -1 there. You could graph it with using slope intercepts. You'd have to change the format here. We could do the same thing with this one here. But the problem is when we substitute 0 for x and we substitute 0 for y, we just get 0 every time. It's going to go through the origin. It looks like it's going to go through the origin. So let's just rewrite that one. So we have -2y. Oops. -2y is equal to -3x. So y is equal to 3 over 2x. Alright, so we're just going to rise of 3 and a run of 2. Okay. So those are my 2 points. I'm starting here. Rise of 3, a run of 2. Alright, and I'm going to go ahead and draw that line. Let's go to insert, get my line here. Alright, so let's do that. I can just keep extending it forever. Alright, I don't need to go down any further. So what do I have to determine here is where do they intersect? Okay, so that would be my height. My height is going to be where they intersect. So I'll just go ahead and draw this here. Let's see. So this is my height here. Alright, and so that's h, the height of the triangle. The base we can see is what? 4 units, right? So we just got to find the area is half the base times the height. So we need to find out what the intersection is there, the y value. That's all we really need. We need to find out what the y value is. Okay. So we have isolated y here. So I could substitute that into the other equation. Let's go ahead and do that. So we have x plus y, and in place of y, I'm going to just put 3 over 2x, right, is equal to 20. Alright, so what are we going to have? That's going to be 5 halves x equals 20. And then so if I multiply by the reciprocal, or let's just do this, let's multiply by 2 to undo the division. So 5x equals 430, right? So x is equal to 8. Okay, but how do I get the y value? Well, let's try that. So y is equal to 3 over 2 times 8, right? That is just going to be 4. So y is equal to 12. Okay. Alright, so y is equal to 12. That seems pretty reasonable. This is 20. The base I said was 4 units, but they're each worth 5. So let's just fix that there. This was 20 units, right? Each of these was 5. Okay, so now how do I find that area with the height is 12? Let's just put the coordinate in there. So we had 8, and this is 12. Right, put that there. All right, so our height is 12, and so the area is equal to a half the base, which is 20, times the height, which is 12. Okay, so 6 times 12 is basically, or 20 is basically it, so 120, and we don't know what the units are, so we'll put units squared. That's it. That's all it's asking for, right?